After just one sleepless night, your brain starts behaving like it's been chemically altered. Your emotional reactions become 60% more explosive. Your ability to make rational decisions collapses. And the part of your brain responsible for keeping you calm essentially goes offline. This isn't exaggeration. This is what neuroscientists have documented in brain scanners, watching it happen in real time. And the worst part? Most people experiencing it have absolutely no idea. Welcome. In this video, we're going inside the sleep-deprived brain, region by region, to show you exactly what changes, why it matters, and what the latest neuroscience reveals about the long-term cost of cutting sleep short. Everything you're about to hear is backed by peer-reviewed research, and by the end, you'll never think about skipping sleep the same way again. Let's start at the front of your brain, the prefrontal cortex. This is the region most associated with what makes you, you. Rational thinking, impulse control, decision-making, and the ability to regulate your emotions. Think of it as the CEO of your brain. When it's functioning properly, it keeps the more primitive reactive parts of your brain in check. Now, here's what happens after even one night of poor sleep. Brain imaging studies show that sleep deprivation significantly reduces metabolic activity in the prefrontal cortex, particularly in the ventromedial regions responsible for emotional regulation and behavioral control. In plain terms, your brain's CEO goes quiet. And here's where it gets dangerous. The prefrontal cortex has one critical job when it comes to emotions. It keeps a leash on a small, almond-shaped structure deep in your brain called the amygdala. The amygdala is your brain's alarm system. It processes threats, triggers fear, and activates the fight or flight response. Normally, your prefrontal cortex talks it down, applying context, logic, and calm. But without sleep, that connection weakens. Researchers at UC Berkeley found that after one sleepless night, the amygdala becomes 60% more reactive to emotionally negative stimuli. Not 6%, 60%. The brain's alarm is going off at full volume, with nobody left to turn it down. This prefrontal amygdala disconnect has real, measurable consequences on how you experience the world. A 2024 study published in the Journal of Sleep Research found that after 24 hours of sleep deprivation, people struggle significantly more with resolving emotional conflict. Not because they don't understand the situation, but because the neural circuitry required to process and override emotional reactions has been compromised. In practice, this means minor frustrations feel catastrophic. A slow driver, an ambiguous text, a small mistake at work. These feel enormous when you haven't slept. Not because the situation changed, but because your brain's ability to properly assess it has broken down. You also become less able to read other people correctly. Research shows sleep deprivation impairs facial emotion recognition, a foundational skill for social interaction. Sleep-deprived people are more likely to misread neutral facial expressions as hostile or threatening. You literally start seeing threats that aren't there. And then there's the decision-making layer. Studies show sleep-deprived individuals exhibit impaired feedback-based decision-making. Even when they receive signals that their choices aren't working, they struggle to adapt. What's particularly unsettling is that people believe they're performing normally. They're blind to their own impairment. Scientists call this the performance gap, the difference between how well you think you're doing and how well you're actually doing. Sleep deprivation widens that gap dramatically. Now let's move deeper into the brain, to the hippocampus. This seahorse-shaped structure is your brain's memory filing system. During sleep, specifically during the deep, slow-wave NREM stages, the hippocampus replays the day's experiences and transfers them into long-term cortical storage. This process is called memory consolidation. When you cut sleep short, this filing system breaks down. A landmark study published in PNAS in late 2024 found that sleep deprivation disrupts the prefrontal cortex's ability to inhibit unwanted memories from intruding. Not only do you struggle to form new memories, you also lose the ability to suppress intrusive ones. Researchers describe this as a failure of memory control, with direct implications for conditions like PTSD and anxiety disorders. But even for healthy people without clinical diagnoses, the implications are significant. Students who pull all-nighters before an exam are not banking on sleep. They are withdrawing from it. The memories formed during that frantic last-minute study session are not being properly consolidated. The brain has no opportunity to do its night shift filing work. And it gets worse. Research shows that sleep-deprived individuals develop stronger, more generalized fear memories, meaning that after a bad experience when sleep-deprived, your brain is more likely to develop an exaggerated, generalized fear response. Small stressors get encoded as big threats, and the brain struggles to distinguish between safe and dangerous situations. Here's something most people don't know about sleep deprivation. It doesn't just make you feel bad. It also makes certain things feel too good. fMRI research published in the Journal of Neuroscience found that sleep deprivation amplifies reactivity throughout the brain's mesolimbic reward network, the same dopamine system involved in addiction. The brain essentially becomes hypersensitive to rewards: food, novelty, stimulation, risk. This is why, after a night of poor sleep, the craving for high-calorie junk food intensifies dramatically. Brain scans show elevated activity in the striatum and amygdala in response to food stimuli, combined with reduced activity in the frontal regions that normally say, "No, that's not a good idea." It's also why sleep-deprived people make riskier financial decisions, are more likely to engage in impulsive behavior, and, in the context of addiction recovery, are significantly more vulnerable to relapse. Your brain's accelerator is stuck down, and the brakes have been removed. The cruel irony is that this combination, impaired prefrontal control plus heightened reward sensitivity, is precisely the neurological signature of early-stage addiction. You don't need a substance. One bad night of sleep can temporarily rewire your reward circuitry. So let's put this all together. When you don't sleep, your brain doesn't just feel tired. Your prefrontal cortex, the rational, regulating part of your brain, loses metabolic fuel and goes quiet. Your amygdala, the alarm system, loses its supervisor and fires 60% louder. Your hippocampus can no longer properly consolidate memories or filter intrusive ones. And your reward system becomes hyperactive, driving you toward impulsive, short-sighted choices. You are, quite literally, not the same person. And here's what makes this so important. Most people experiencing these effects don't recognize them as sleep-related. They attribute their irritability to their job, their bad decisions to stress, their emotional outbursts to their relationships. But a significant driver may simply be the chronic, low-grade sleep debt that has become completely normalized in modern life. The good news is that the brain is remarkably responsive to sleep recovery. Even a single night of good sleep begins to restore prefrontal amygdala connectivity. Emotional reactivity drops. Clarity returns. The CEO comes back to work. Sleep isn't a luxury. It is literally the process by which your brain rebuilds its capacity to be human. If you found this useful, subscribe, because next, we're covering something that might surprise you even more: the science of why you cannot catch up on lost sleep, no matter how long you sleep on the weekend. The research is not what most people expect. See you there.